So at this moment in time, there is some velocity vector of the particle given by this vector, which I will call the velocity vector at time t. And then we have the velocity vector of the particle at time t plus dt. Okay. So now we define acceleration, the acceleration vector, as the velocity at time t plus dt minus the velocity at time t whole divided by dt. Okay, and as you know, this is basic calculus. So this will be dv by dt. So what is the meaning of velocity as a function of time? Remember, I told you that it is a vector and a function. So what you have learned in a vector and what you have learned in a function are both present here, right? So an example of velocity vector as a function of time would be, if I want to scare you, would be 5e raised to the power minus 2t. For example, I cap plus 3t j cap plus 5 k cap. This would be the an example of the of a velocity vector, right? It is a function of time and it is a vector quantity. Okay, so the types of motion. So the types of motion will be one-dimensional, two-dimensional, or three-dimensional. Okay, they may also be, now this is a separate classification. So other kind of types of motion. So this is a separate classification. This may be zero acceleration, constant acceleration, and variable acceleration. All I'm saying is that there are three types of, there are various classifications of motion, right? You can classify motion in a variety of ways. The three types of classification are that the motion can be one-dimensional, two-dimensional, or three-dimensional, right? So this would be one-dimensional motion. Okay, this would be one-dimensional motion, only along the y-axis. Okay. This would be two-dimensional motion. Okay, and if I throw it like this, so that it is going here, then this would be three-dimensional motion.